using a motor grader is to recover the aggregate from the edge of the road, mix it with the fines, and spread it back across the roadway. Some of the basic movements of the blade and how they can be utilized. These basic movements are blade lift, blade angle, blade pitch, and blade shift. The first movement is blade lift. It is possible to raise and lower both ends of the blade evenly or just one end at a time. To create a level movement of the blade, set both ends of the blade at the same height. To create a crown or slope, position one end higher than the other. A blade barely touching the surface of the road is called a loose blade. A loose blade is used primarily for spreading and mixing of the material to create a dragging action. In contrast, a tight blade has enough downward pressure to actually cut into the surface of the road. Having the toe, or the forward end of the blade tighter than the heel, or the rear end of the blade, causes the material to move across the blade. The next movement is blade angle. On all graders, the blade is mounted on a circular mechanism, mounted on the center of the grader's frame. This mechanism can be rotated clockwise or counterclockwise throughout a full 360-degree turn. A blade perpendicular to the frame of the grader or straight across is considered to have a 0-degree spreading angle. For most jobs to be done using the motor grader, the blade angle varies from 15 to 45 degrees. Increasing the spreading angle increases the ability to move material across the blade and windrow it. It is important that material be windrowed outside the rear wheels of the vehicle so that they do not ride over it. The next movement is blade pitch. Blade pitch refers to the vertical angle of the blade. The blade can be tilted forward, backward, or remain in an upright position. A forward angle of the blade creates a dragging action on the road. The blade does not cut into the roadway surface. A backward pitch is used for cutting or reshaping of the road. Use backward pitch in conjunction with enough downward pressure to create a cutting action. The majority of jobs are performed with the blade in an upright position or tilted forward slightly to get a mixing and compacting action of the material. The last movement is blade shift. Blade shift is the extension of the blade sideways beyond its normal position. The extensions vary depending on the job to be done. Blade shift allows the motor grader to reach areas farther away from where the tires must run. This is useful to avoid running the motor grader in wet areas. So, these are the 4 basic blade movements: blade lift, blade angle, blade pitch, and blade shift. All graders have the capability of leaning the front wheels. The ability to lean the front wheels allows the grader to make sharper turns. In addition to turning, wheel lean is important when performing various maintenance operations. In general, lean wheels in the direction that material is being bladed. This counteracts the pulling action placed on the motor grader by the blade. Usually, wheel lean should be 10 to 15 degrees in the direction that the material is moving. Now, let's look at the basic maintenance procedures for gravel roads. The first operation is the routine machining of gravel roads. The objective of routine machining is to recover the aggregates from the edge of the roadway and redistribute them back across the road. This is accomplished by the dragging and smoothing action of the blade. During this operation, be careful not to break the crust of the road. Do not perform this operation during dry weather, as the machining action will cause the fines to be blown away. It is best performed after a rain, while the road is damp. Prior to the first pass, set the blade angle to pull material from the shoulder toward the center of the road. In general, this blade angle is 30 to 45 degrees. Pitch the blade forward slightly to create a dragging action rather than a cutting action. Maintain proper crown to allow for drainage. Set the blade higher at the center of the road than at the edge. Do not put enough downward pressure on the blade to cause the blade to cut into the crust of the roadway. Proceed at a slow, steady speed, generally 3 to 5 miles per hour. Speeds faster than this may cause the blade to bounce and create an unevenness in the surface of the roadway. Pull materials from the shoulder of the road across the blade, forming a windrow near the center of the road. Be careful that material does not spill off the toe of the blade and create a windrow at the shoulder of the road. This creates a small berm or secondary ditch and prevents the drainage of water off the surface of the road. Make an additional pass to spread the material across the full width of the road. Spread the windrowed material in the center of the road toward the opposite shoulder. Again, set the blade height to match the desired crown or slope of the road. Be careful not to form a windrow with the heel of the blade. Spread the windrowed material smoothly and evenly across the road. Additional passes may be necessary depending on roadway width. The next cycle of routine machining is performed traveling in the opposite direction to recover aggregate from the other side of the road. This is the result: a smooth gravel road with aggregate spread across the road with proper crown. The other maintenance operation is reshaping of gravel roads. Eventually, due to a combination of weather and traffic, the crust of the roadway may be broken down, creating a rough riding surface. The surface may have potholes, washboarding, and rutting. A roadway in this condition must be reshaped and requires cutting through the crust of the roadway to create a new smooth surface. Reshaping of gravel roads should be done when the roadbed is moist. A dry, hard surface is difficult to cut and may also quickly damage the blade. To begin the reshaping operation, pitch the blade slightly back to create a cutting action. Angle the blade 30 to 45 degrees so the material is carried toward the center of the road and windrowed there. Lean the wheels 10 to 15 degrees in the direction that the material is to be moved. Proceed at a steady but slow speed, 3 to 5 miles per hour. Use enough downward force on the blade so that it cuts to the bottom of the potholes, washboarding, and rutting that exist in the roadway. There may be instances where potholes are so deep and extensive they cannot be repaired simply by the cutting action of the blade. In these cases, scarify the potholes at least 2 to 4 inches below the bottom of the hole prior to reshaping. This loosens the material and allows it to be reshaped, thus eliminating the pothole. On the second pass, spread the windrowed material back across the same side of the roadway, restoring the original crown and shape of the road. Be careful not to create a secondary ditch at the toe of the blade. Repeat this procedure on the other side of the roadway. The end product is a smooth road with proper crown and shape to allow for drainage. Potholes, ruts, and washboards have been eliminated. The combination of dry weather and compaction under traffic causes a new crust to be formed on the surface of the road. In the maintenance of gravel roads, there are several special situations that the motor grader operator must address. These special situations are intersections with another gravel road, intersections with a paved road, railroad crossings, driveways, bridges, hilltops, valleys, and super elevation in curves. Each of these special situations will be discussed briefly. It is important for the operator to handle each of these in the appropriate manner. The first special situation is the intersection with another gravel road. In the machining operation, gradually eliminate the crown, beginning 50 to 100 feet back from the intersection. Continue this transition such that the crown is totally eliminated at the intersection point. Follow this procedure for all 4 legs of the intersection. This means that the intersection is essentially flat, allowing smooth transition for a driver passing through the intersection. The next special condition is an intersection of a gravel road with a paved road. Again, gradually eliminate the crown on the gravel road, beginning 50 to 100 feet back from the intersection. This transition is smooth, with the crown being totally eliminated at the intersection point. Do not leave loose aggregate spilled onto the paved surface. This creates an unsafe condition for motorists on the paved road. To eliminate this problem, pull forward onto the paved road. Place the blade down on the pavement and backblade any aggregate that has been pushed onto the paved surface. Check behind the motor grader before backing up. In some cases, it may be necessary for the operator to get off the motor grader and use a shovel to remove loose aggregate that remains on the paved surface. The next special condition is railroad crossings. Again, begin to eliminate crown 50 to 100 feet back from the railroad crossing. This transition is smooth, with the crown being totally eliminated at the crossing point. Do not push any aggregate material onto the tracks. This could create a hazard for trains passing through the crossing area. The material may need to be backbladed to smooth the crossing area. Push material up to the edge of the crossing area, then lift the blade over the material and place it down in front of it. Backblade the material in the reverse direction, smoothing the material out from the railroad crossing. If necessary, use a shovel to remove loose material from the tracks. Create a transition on the opposite side of the railroad crossing. In 50 to 100 feet, gradually build the crown back into the surface of the roadway. The next special condition is driveways. Although governmental agencies are not in the business of maintaining driveways, a smooth transition is desired for driveways onto the road surface. It is not good public relations to leave a large bump or big drop-off at the end of a driveway along the roadway. Allow for smooth transition at driveways when performing maintenance on gravel roads. The next special condition is a bridge on a gravel road. Gradually eliminate crown 50 to 100 feet back from the edge of the bridge. Transition the road to match the shape of the bridge at the intersection point. Be careful not to leave excess loose aggregate on the surface of the bridge, as this could create a safety hazard. To eliminate this, lift the blade at the edge of the bridge and backblade across the surface of the bridge to remove the loose material. When necessary, use a shovel to remove excess material. On the opposite side of the bridge, transition back to the normal crown of the road in about 50 to 100 feet beyond the bridge. The result is a smooth transition between the bridge and roadway. Another special condition is machining over hilltops. If the blade height is not adjusted on the grader, this will cause the top of the hill to be cut off. Gradually raise and lower the blade as the grader passes over the crest of the hill. Valleys or low points of vertical curves also create a special condition. Lower the blade somewhat in the low point of the valley to follow the profile of the road. Then gradually raise the blade as the grader moves on to the uphill grade. The last special condition the motor grader operator will encounter is superelevation in curves. Superelevation is needed for safety purposes. It allows vehicles to go through the curve at a normal speed without being forced off the roadway due to centrifugal force. The tighter the curve, the more superelevation would be needed for vehicles passing through it. Transition from the normal crown to superelevation, 50 to 100 feet back from the beginning of the curve. Transition from the superelevation back to the normal crown, 50 to 100 feet beyond the end of the curve. It is important that all of these special conditions be handled properly in the maintenance of gravel roads. One source of information that may be useful is the publication entitled Blading Aggregate Surfaces, prepared by the National Association of County Engineers. This is a good reference for the maintenance of gravel roads. We will now briefly review maintenance of gravel roads. The importance of gravel roads and the need for their proper maintenance has been discussed. A good gravel road has a hard crust formed on the surface of the road to carry traffic and to shed water from the surface. This crust is formed by a combination of large aggregates, smaller aggregates, and fines mixed together and compacted under traffic. The motor grader is the primary piece of equipment used in the maintenance of gravel roads. Routine machining recovers aggregate that has been carried to the edge of the road by traffic and redistributes it back to the center of the road. The steps to be performed in routine machining are: number 1, the first pass of the motor grader pulls aggregate from the shoulder and windrows it at the center of the road. The blade creates dragging action and does not cut the crust of the road. Number 2, the second pass spreads aggregate across the opposite side at the proper slope. Number 3, the next routine machining cycle is performed in the opposite direction. The other basic type of gravel road maintenance is reshaping or cutting of the roadway surface. Reshaping is required when the crust of the roadway has deteriorated due to traffic and weather. Reshaping eliminates ruts, potholes, and washboards. The steps required are: number 1, scarify ruts, potholes, or washboards that cannot be cut by the blade. Number 2, use motor grader to cut crust of roadway and windrow material at the center of the road. Number 3, spread windrow back across the same side of the road at the proper slope. Number 4, repeat cutting and spreading operation on the other side of the roadway. The result of proper gravel road maintenance looks like this. The surface is smooth, with aggregates spread evenly. The shape of the road is crowned properly for good drainage. Gravel roads maintained in this condition can best serve the traveling public. North Carolina Institute for Transportation Research and Education presents Pavement Structure Repair Techniques, Ditch Maintenance. A wise old highway maintenance engineer once said, "You only need 3 things to have a good road. That is, drainage, drainage, and more drainage." Obviously, a good drainage system is important to the performance of the roadway. Ditches constitute a valuable and integral part of a drainage system for a road system. It is important that they function properly to allow for good drainage of roads. When ditches become clogged with silt or debris, they are not able to function and provide the needed drainage. If this situation exists, road conditions will suffer due to the lack of drainage. This videotape provides instruction on the proper techniques for ditch maintenance. Let us first talk about how drainage is important and how ditches relate to the drainage of a typical roadway. This is a cross-section of a typical road. Notice the construction of the roadway. There is a layer of asphalt surface and a layer of aggregate base material. These layers rest on the subgrade. Notice that the surface of the roadway has a crown or slope in order for water to drain from the surface of the road across the shoulders and into the ditches along the side. The ditches can then carry the water away from the roadway, thereby protecting it from water damage. If water is not drained away from the roadway, it can penetrate the roadbed and weaken the pavement layers. A weakened roadway will exhibit distress and failure. In addition to carrying surface water that drains off the roadways, ditches also can prevent underground water from seeping into the subgrade and base materials of the road. Keeping the ditches lower than the roadbed causes underground water to flow along the ditches and not up into the roadbed. Here is a ditch where the original flow line has been obstructed by sediment and debris. This situation will occur over time on many roads due to erosion and litter. This ditch cannot function properly as the flow of water is obstructed. The three goals of ditch maintenance are to 1. Clean out the ditch, 2. Reshape the ditch, and 3. Establish the original flow line along the bottom of the ditch. This will allow water to drain properly through the ditch. Ponding of water in ditches must be corrected. Ponded water can seep into the shoulder and base material underneath the road. This weakens the road structure, and traffic will cause the pavement to break up. Water standing along the entire length of a ditch should also be corrected. It is important that one end of the ditch be higher than the other. This ditch does not have a proper flow line. Water is a principal cause of many structural pavement failures. Providing proper drainage through ditch maintenance is preventive maintenance and will allow pavements to last much longer. There are two primary pieces of equipment that are used to perform ditch maintenance. They are the motor grader and the hydraulic excavator. The appropriate piece of equipment to be used is determined by the area where ditch maintenance is to be performed. The width of shoulder and amount of material to be removed is considered when selecting the piece of equipment. Other pieces of equipment that are used in ditch maintenance include a backhoe, a front-end loader, a belt loader, and dump trucks for hauling. As in any maintenance operation, it is extremely important that proper traffic control procedures be followed to ensure safety of the motoring public, as well as the maintenance personnel. For more information on traffic control, refer to the videotape Basic Traffic Control for Pavement Structure Repair Techniques. Once proper traffic control is in place, the ditch maintenance operation can begin. First, let's discuss ditch maintenance using a motor grader. Use a motor grader for long ditches that are uninterrupted by driveways and pipes. Here, the motor grader can operate for a long distance without delay and do a more efficient job. Do not use a motor grader on short, wet ditches. The motor grader does not have the maneuverability to do this job efficiently, and wet areas cannot support the weight of the motor grader. In addition to the motor grader, a loader is needed to load the material removed from the ditches into dump trucks. This could be either a front-end loader or a belt loader. The steps to be followed in this operation are: number 1, place proper traffic control. Number 2, clean inlet and outlet pipes and outlet ditches. Number 3, clean out ditch with motor grader. Number 4, load material into trucks for proper disposal. Number 5, remove traffic control. Prior to using the motor grader, use a backhoe to clean out around pipes and outlet ditches. It is difficult for a motor grader to clean out properly around the ends of these pipes. If necessary, do this by hand and remove this material as a part of the ditching operation. Position the motor grader with its wheels in the bottom of the ditch. Use a 10 to 15 degree front wheel lean in the direction that the material is being moved. Angle the blade approximately 45 degrees. Set the toe of the blade at the bottom of the ditch. Set the heel at the proper height to obtain the desired ditch side slope. Pull material from the bottom of the ditch across the foreslope and windrow it at the edge of the shoulder. Proceed at a slow speed, not more than 3 to 5 miles per hour, while performing this operation. This prevents the blade from bouncing and creating an uneven flow line in the ditch. Make minimal changes in the height of the blade during the operation so that the result will be a smooth ditch. Be careful not to undercut the back slope. Undercutting the back slope will cause the slope to erode and prematurely obstruct the ditch in the future. Pick up the material removed from the ditch with a front-end loader and load it into the waiting trucks. An alternative method of removing the material is the use of a belt loader. However, to use the belt loader effectively, the material removed from the ditch must be bladed across the shoulder and windrowed along the edge of the pavement. Move the belt loader along, picking up the material and loading it into the waiting dump trucks. Ditch maintenance with a motor grader results in a V-shaped ditch with a well-groomed back slope and foreslope. The ditch is cleaned out to the original flow line and has a smooth flow line so that water will move freely down the ditch. Now, let us review the steps followed in this operation. Number 1, place proper traffic control. Number 2, clean inlet and outlet pipes and outlet ditches. Number 3, clean out ditch with motor grader. Number 4, load material into trucks for proper disposal. Number 5, remove traffic control. Now, let's discuss ditch maintenance utilizing the hydraulic excavator. Use the hydraulic excavator in areas where a motor grader cannot operate because of wet conditions. Also, it is more efficient to use a hydraulic excavator instead of a motor grader on a road with many driveways and pipes. The steps to be performed are: number 1, place proper traffic control. Number 2, clean inlet and outlet pipes and outlet ditches. Number 3, remove material from ditch with excavator, creating proper shape and flow line. Number 4, load material into trucks for proper disposal. Number 5, remove traffic control. The equipment needed for this operation is the hydraulic excavator and dump trucks to haul material away from the job site. Clean the inlets and outlets prior to ditch maintenance. This can be done with a backhoe or by hand. Remove this material as a part of the ditch maintenance operation. Position the hydraulic excavator totally on the shoulder of the road if possible. remove material from the ditch using the bucket. Clean the ditch to create a U-shape with smooth sides. Lower the ditch to the original flow line. The bottom of the ditch is smooth with the desired gradual slope. As the material is removed, load it into a dump truck. Take care not to disturb the back slope of the ditch to prevent future ditch erosion. Also, be careful not to undercut the back slope. This might cause back slope material to slough off into the ditch. Do not disturb more natural vegetation than is necessary. This will minimize future erosion from these areas. Also, be careful to properly shape the ditch at the inlet and outlet of any pipes. A smooth ditch line at both ends of the pipe allows water to flow properly through the pipe. The supervisor determines the proper number of trucks needed for the hauling operation. This is important to the overall progress of the ditch maintenance operation. It is important that the excavator not have to idle while waiting for trucks to haul the material away. The number of trucks required is of course dependent upon the haul distance and the loading time of a truck. There is a simple way to determine the number of trucks needed. First, estimate the time required to load a truck. Then, estimate the round-trip haul time required for a truck to empty a load. Then, divide the loading time into the round-trip haul time and add 1. This results in the number of trucks needed to support the ditching operation. This allows for a continuous moving operation with no delays due to lack of trucks. For example, suppose the estimated load time is 15 minutes and the round-trip haul time is 30 minutes for each truck. How many trucks need to be assigned to this job? 30 minutes, the haul time, divided by 15 minutes, the load time, is 2, plus the added 1 means you assign 3 trucks to this particular job. This arrangement minimizes the time trucks spend waiting to be loaded, as well as wait time for the excavator. The proper number of trucks makes the ditch maintenance operation more efficient. Let us review briefly the steps required for ditch maintenance with a hydraulic excavator. Number 1, place proper traffic control. Number 2, clean inlet and outlet pipes and outlet ditches. Number 3, remove material from ditch with excavator, creating proper shape and flow line. Number 4, load material into trucks for proper disposal. Number 5, remove traffic control. Remember the 3 basic goals that are accomplished by performing proper ditch maintenance. The first is cleaning out the ditch. Remove dirt, debris, and other such materials. The second is proper reshaping of the ditch. Reshape the ditch to its original cross-section. This should be a well-groomed, smooth V or U-shaped section. And the third goal accomplished is to restore the flow line of the ditch. The flow line is a smooth grade. Remember, it must be higher upstream than downstream. The ditch has no dips or low spots that allow water to pond. By performing ditch maintenance, we allow roads to drain properly. This is a preventive maintenance activity and should reduce the amount of costly pavement failures that might occur. Ditch maintenance is mandatory to protect the tremendous investment in a roadway system. North Carolina Institute for Transportation Research and Education presents Pavement Structure Repair Techniques, Pothole Patching. It seems that there's never enough time to fix a pothole correctly, but there's always time to go back and do it again. The bombardier method of pothole patching is one way to ensure a return trip to this pothole. Effective pothole patching does not happen by chance, but results from following a defined set of procedures. Proper pothole patching extends the useful service life of an existing pavement structure and delays the time when an overlay or more extensive pavement maintenance becomes necessary. The objective of this presentation is to illustrate a clear, simple, and effective pothole patching procedure for use by small road maintenance crews. What are potholes? Potholes are bowl-shaped pavement failures which occur in the surface or surface and base of a street. The failures usually occur in areas of severe alligator cracking. Alligator cracking is a load-associated failure and occurs in the wheel path area. Surface pothole failures, sometimes called pop-outs, look like this and usually occur in the top pavement layer. Surface and base pothole failures are ones which progress down through the surface into the base. What causes potholes? Potholes can be caused by 1. Inadequate structural thickness, 2. Poor drainage, 3. Overstressing the pavement with excessive loads, 4. Lack of subgrade or base support, 5. Poor pavement construction. 2 factors must be present at the same time for potholes to form. These factors are number 1, water, and number 2, traffic. When water enters the base of the pavement, it weakens the pavement and reduces its ability to carry traffic. Water reaches the base materials either by intrusion through cracks in the pavement surface, or standing water may seep into the base from the shoulder area where there is poor drainage. Combine the weakened base condition due to water with traffic, and potholes occur. The need now is to repair the pothole. Proper pothole repair requires the following pieces of equipment. 1. A pavement cutter. 2. An asphalt distributor. 3. A compactor or roller. 4. A truck. Various types of pothole patching equipment are available. Self-contained units that have all the essential equipment make pothole patching a very efficient operation. Pothole repair procedure. A 6-step procedure is presented for repairing potholes. This procedure will result in permanent repair and eliminate return trips. The 6 steps for proper pothole repair are: 1. Identify and mark. 2. Cut. 3. clean. 4, tack. 5, place. 6, compact. Each of these 6 steps will be discussed in detail. As in all pavement maintenance activities, proper work zone traffic control is necessary for the safety of the work crew and the traveling public. The supervisor should consult the MUTCD or other appropriate work zone traffic control standards to determine the appropriate traffic control needs for the given situation. For more information, refer to the videotape Basic Traffic Control for Pavement Structure Repair Techniques. With proper traffic control in place, maintenance personnel begin the pothole repair. The first step in the 6-step pothole repair procedure is to identify and mark the areas to be patched. This is best done by a supervisor or crew leader ahead of the patching operation. This enables the crew to begin work as soon as it reaches the site. Marking the proper amount of material to be removed is important. Removing too little material will result in future failure. Removal of too much results in excess work and reduced productivity. How do you properly mark the pothole areas for patching? There are 2 key points to remember. First, mark an area that extends 8 to 10 inches into sound pavement. This provides a good surface against which the patch can bond and provide containment of the patch material. Marking is done with spray paint or chalk. Second, make straight edges forming a square or rectangle around the pothole. Proper marking ensures that the correct amount of material will be removed in the patching operation. The second step in the patching procedure is cutting. Cutting prevents damage to surrounding pavement when removing material and provides a vertical face for containment and bonding with the patch material. Use a pavement cutter to cut out the marked area. A sharp bit improves the cutting rate and reduces the damage to the pavement during the cutting operation. Begin cutting near the center of the pothole, forcing the material in toward the center. Take care when using the pavement cutter not to rock it during the cutting operation. Rocking causes damage to the stable pavement, resulting in cracking. Cutting depth is also important. Cutting continues to a depth where good pavement or base material exists. Make the final cut along the marked edges of the patch area, thus providing a vertical face around the edge of the patch area. A pavement saw may also be used to remove the distress area instead of a jackhammer or other pavement cutter. The third step in the patching procedure is cleaning. This step involves the removal of all loose material and water so that a clean surface is available for the bonding of the tack coat and patch material. Remove material down to stable pavement or base material. Remove large pieces of material with a shovel. Sweep up smaller pieces with a stiff broom and shovel them out. Pay particular attention to the corners of the patch area so that loose materials do not build up there. Load the material removed on the truck for disposal. Use compressed air for removing small debris if available. If water is present in the hole, then it must be removed. Dry the hole using compressed air, rags, or a broom. Once all loose materials have been removed, compact the disturbed base or subgrade at the bottom of the patch area prior to placing the asphalt patch material. Use a vibratory tamp or hand tamp for this compaction. The hole is now ready for the fourth step in the patching procedure, tacking. A tack coat is a thin layer of liquid asphalt which provides a bond between the old and new materials. Tack the bottom and sides of the patch area in an even thin coat. Too much tack will soften the pavement and cause bleeding or shoving of the patch. Too little tack will result in a poor bond. The best method of applying tack is by spraying. This provides a thin and uniform coating. Pouring is not recommended because it results in an accumulation of excess asphalt at the bottom of the hole around the edges. If a tack coat cannot be sprayed, brush it uniformly onto the sides of the patch area. The fifth step in the patching procedure is placing of the patch material. Placing is the action of filling the cleaned and tacked hole with patch material. A dense graded hot mix asphalt is preferred for pothole patching. It may be necessary to use a cold mix if hot plant mix is not available. Experience has shown the cold mix does not perform as well as hot mix. Place the patch material in lifts of approximately 3 inches or less. Compact each lift separately. The patch material should be workable. Do not use material that has cooled and is not workable. Plant mix that has cooled cannot be properly compacted. Place patch material evenly to avoid segregation. Avoid throwing the material in the hole because it causes segregation. Use the back of the shovel to tap material against the edges and in the corners of the hole. Use a lute if the material needs to be smoothed out. Avoid excessive raking, as this will also cause segregation. Remove any spillage outside the hole to prevent the roller from riding on it and not properly compacting the material in the hole. Use a shovel to remove this excess material. Compact the material as soon as it has been placed. This is the sixth step and one of the most important. If the material gets cold, it cannot be compacted. Poor compaction will result in depression under traffic and ultimate failure of the patch. Use compaction equipment that matches the size of the repair. For most potholes, a small to medium-sized vibratory plate compactor or roller is sufficient. The small vibratory plate compactor allows intermediate lifts to be compacted inside the confines of the hole. Following the compaction of the first lift of asphalt, place and compact the next lift. Place the final lift such that it will match the elevation of surrounding pavement after compaction. When compacting the final lift, especially with rollers, take care to ensure that the compaction force is directed on the patch and not the surrounding pavement or spillage. Straight edge the finished patch to assure that the surface of the patch is even with the surrounding pavement. Do not overfill the patch in anticipation of compaction by traffic. Following the compaction operation, remove any loose materials and all equipment from the work site. Then remove traffic control devices. Now let's review the 6 steps of the pothole repair procedure. 1. Identify the area which needs to be repaired. Mark the area to be cut out with spray paint or chalk. Remember, the marked area extends back into sound pavement and has squared up straight edges. 2. Cut out the failed material using a pavement cutter. The cutting provides vertical walls extending down to good pavement or base material. Do not rock the pavement cutter while cutting. 3. Clean out all loose materials. Remove the large materials with a shovel and the small materials with a broom and compressed air if available. Remove any water and dry the patch area completely if it's wet. Tamp the bottom of the hole to compact the disturbed base or subgrade. 4. Tack the sides and bottom of the patch area. Preferably, spray the tack with a wand. Brushing is acceptable if a spray applicator is not available. A thin, uniform coating is desired. 5. Place the plant mix asphalt evenly in a maximum lift thickness of 3 inches. Take care when handling the mix to avoid segregation of the material. 6. Compact the material as soon as the asphalt is placed. Compact each lift separately. Compaction of the top layer of asphalt should leave the patch elevation even with the surrounding pavement. Following these simple steps will result in a permanent pothole repair. This patch will perform as long or longer than the surrounding pavement. Proper repair of potholes is very important in maintenance of the road system. The North Carolina Institute for Transportation Research and Education presents Pavement Structure Repair Techniques, Crack Sealing.
So do you think we should seal these cracks?
I think so. The cracks are about a 1/4 inch wide. If we seal them now, we can keep the water out of the base and prevent further deterioration.
Crack sealing in asphalt pavements has long been a cost-effective pavement maintenance activity. However, unless it is performed properly, the benefits are minimal to the pavement or the traveling public. The objective of this presentation is to illustrate a clear, simple, and effective crack sealing procedure for asphalt pavements. This procedure is designed for small road maintenance crews. The purpose of crack sealing is to prevent surface water infiltration and thus slow the rate of pavement deterioration. A 4-step procedure will be presented for sealing cracks. Following these steps will result in effective crack sealing and an extended pavement life. The 4 steps are: 1. Crack analysis and identification. 2. Crack cleaning and preparation. 3. Application of sealant. 4. Squeegee cracks. Before these activities can begin, however, proper traffic control measures must be in place. The supervisor should consult the MUTCD or other appropriate work zone traffic control standards to determine the traffic control needs. For more information, refer to the supplemental videotape, Basic Traffic Control for Pavement Structure Repair Techniques. With proper traffic control in place, the crack sealing operation can begin. The equipment needed for crack sealing includes an air compressor, preferably with a hot air lance, an asphalt distributor with a wand applicator, and a squeegee. The first step in the crack sealing process is performing crack analysis and identification. This is done to identify those pavements which exhibit the type and severity of cracking that warrants crack sealing. Block cracking, also called shrinkage cracking, is a distress which often warrants crack sealing. Daily temperature changes cause expansion and contraction in the pavement. As the pavement ages and hardens, it is less able to withstand this stress. It pulls apart, creating block cracks. Block cracking most commonly occurs on plant mix pavements. Block cracking begins as transverse cracks. These transverse cracks eventually become connected with longitudinal cracks, forming blocks, hence the name block cracking. Block cracks are not a load-associated pavement distress and do not represent a structural failure of the pavement. However, if these cracks are not sealed, water can freely enter the base and subgrade. This will weaken the pavement and lead to structural problems. A widening joint also needs to be sealed when open. Usually, a crack will form along the joint between the original pavement and the widening strip. Reflective cracking also requires crack sealing. This cracking occurs where Portland cement concrete pavement has been overlaid with asphalt. Usually, the joints and cracks in the concrete pavement will reflect to the surface. These cracks should be sealed to prevent water and incompressible material from entering them. Crack sealing is an effective maintenance activity for all of these types of cracks. Cracks must be wide enough for the sealant to enter the crack. Cracks should be approximately 1/4 inch wide. A rule of thumb: if a pencil will stand up in the crack, it needs to be sealed. It is not cost-effective to seal all cracks. For very narrow cracks, other sealing techniques, such as slurry seal, may be used. Some pavement sections may have extensive block cracking with small blocks of 2 to 10 square feet formed. Alternate maintenance repair procedures, such as chip seals or overlays, need to be considered. For these conditions, crack sealing would be too time-consuming and expensive to be cost-effective. The preferred time of year for crack sealing is the winter, when cracks are their widest. However, rubberized asphalt sealants make year-round crack sealing possible. The second step is crack cleaning and preparation. A clean and dry crack is essential if an effective bond is to be formed between the crack sealant and the pavement. Clean the cracks with compressed air, or preferably a hot air lance. Compressed air effectively removes dust, sand, and other incompressible matter from the crack, providing a clean face for bonding. The hot compressed air lance combines high pressure with a flame to heat the air. This dries and cleans the crack at the same time. In addition, the asphalt pavement is heated somewhat, and the asphalt binder is softened to aid the bonding of the sealant. The hot air lance also burns away organic matter in the crack that would interfere with the sealant bond. The operator is careful to keep moving so the lance does not burn and damage the asphalt pavement. The hot air lance ensures a dry surface for the sealant bond. Often the surface of a pavement appears dry, but moisture remains in the cracks below the surface. The hot air lance dries this latent moisture. Clean the cracks of loose debris to a depth approximately equal to or slightly greater than the crack width. With the cracks now clean and dry, the third step is the application of the crack sealant. Selection of an appropriate crack sealant is essential if the crack sealing operation is to be effective. What are the requirements for a good crack sealant? A high-quality sealant should exhibit the following: good bonding or adhesion characteristics, flexibility and extensibility, ease of application, resistance to softening, resistance to tracking, adequate pot life at application temperatures, resistance to weathering, compatibility with asphalt pavement, rapid curing. In many areas, cutback asphalt, emulsified asphalt, and lean sand asphalt have been used for crack sealing. These materials have yielded mixed results, but generally provided a short service life. In response to a need for a better asphalt crack sealant, numerous proprietary sealing materials have been developed. Most of these products can be classified as some form of rubberized asphalt. These rubberized asphalt materials are relatively expensive, but are more effective, with an expected service life of 3 to 5 years. Rubberized asphalt sealant is recommended for effective crack sealing. Rubberized asphalt sealant requires special equipment for handling and application. Take care to maintain proper temperature of the material. Follow the manufacturer's recommendations for handling and placing sealants for best results. Step 3 is the application of the crack sealant. Place the sealant using an applicator wand attached to a sealant machine. The use of a wand ensures that proper application temperature is maintained and eliminates additional handling of the material. Pour pots have traditionally been used for crack sealing. Though not preferable, they can be used with rubberized asphalt. The sealant may cool quickly in the pot and need to be reheated. This is more critical during cold weather application. Rubberized asphalt sealant is placed at high temperatures, so safety must be emphasized. Workmen must wear gloves for protection. Fill the crack to a level equal to the surface of the pavement. Do not overfill the crack, because this creates a buildup of material on the surface. It may be torn away during snow plowing and may cause a poor ride quality. For cracks wider than 1 inch in width, conventional crack sealing procedures will probably not suffice. It is suggested that the crack be cleaned and a lean sand asphalt type mix be inserted and tamped. The fourth step is to squeegee the just sealed cracks. The squeegee operation levels and smooths out any excess sealant. It results in a thin film of sealant across the pavement that aids in sealing the crack. This operation follows immediately behind the applicator, usually within 5 feet. This is necessary because the sealant material cools quickly and is difficult to squeegee once it cools. Rubberized asphalt sealants do not require any blotting material after application. Once the sealant has cooled, the road is ready to be open to traffic. The time required is approximately 15 minutes. Now, let us briefly review the 4 steps of crack sealing. The first step is to perform a crack analysis and identification. This is a review of pavement sections to determine which exhibit the conditions warranting crack sealing. Block or shrinkage cracks, widening joints, and reflective cracks should be sealed. Crack widths of approximately 1/4 inch wide require crack sealing. A rule of thumb: if a pencil will stand up in a crack, it is wide enough to be sealed. The second step is crack cleaning and preparation. Cracks must be clean and dry for sealants to bond to the pavement. The best method of crack cleaning and preparation is the use of a hot air lance. The hot air lance removes dust, sand, and other debris from the crack and also dries any latent moisture which may remain in the crack. It also heats the asphalt surface and softens the asphalt binder, aiding in bonding of the sealant. Any organic material is also burned away. Clean cracks of all loose debris to a depth equal to or slightly greater than the crack width. The third step is sealant application. Proper application of the sealant is critical if the sealant is to perform effectively. A rubberized asphalt sealant is recommended. It exhibits the desired requirements for a good crack sealant. Maintenance of proper material temperature is important. Follow all manufacturer's specifications for handling and placement for best performance. Apply the sealant with an applicator wand attached directly to a sealant machine. Fill cracks to a level equal to the surface of the pavement. Overfilling of cracks should be avoided because this buildup is susceptible to removal by snowplow operations and results in a poor ride quality. Squeegeeing of the cracks is the fourth step in this procedure. Use a handheld squeegee to smooth out any excess sealant after application by the sealant wand. The squeegee follows immediately behind the application wand because the rubberized asphalt cools quickly. Once the sealant has cooled, the roadway is open to traffic. No blotting is required with rubberized asphalt. Using these operating procedures will result in effective crack sealing and will protect the pavement and retard future deterioration. The North Carolina Institute for Transportation Research and Education presents Basic Traffic Control for Pavement Structure Repair Techniques. This tape supplements the 6 videotapes on pavement structure repair techniques. Proper worksite traffic control is necessary for the safety of the work crew and the traveling public. Also, there is legal liability on the governmental agency to use established traffic control measures. Never begin repair operations until proper traffic control measures are in place. Proper traffic control begins with a plan. The supervisor consults the MUTCD or other appropriate work zone traffic control standards to determine the proper traffic control needs for the given situation. In pavement structure repair techniques, the operations require two basic types of traffic control. Number one, a stationary or very slow-moving activity that is essentially stationary. This includes pothole patching, shoulder maintenance, and ditch maintenance. And number two, a continuously moving activity. This includes crack sealing and asphalt chip seals. First, let us discuss traffic control for a stationary operation. Proper traffic control guides motorists in a clear and positive manner through the maintenance work area. This diagram illustrates a typical traffic control layout for a stationary maintenance operation on a two-lane roadway. It is necessary to close one lane for a short period of time. Use a series of 3 warning signs on both ends of the work area. Place them in sequential order, beginning with Road Construction Ahead sign, then the 1-lane road ahead sign, and lastly, the Flagman Ahead sign. The warning signs are orange and reflectorized. The minimum size of these signs is 36 by 36 inches for a speed limit less than 45 miles per hour. For speed limits greater than 45 miles per hour, the minimum size is 48 by 48 inches. The spacing of the signs is dependent upon the speed of the traffic on the roadway. This table lists the required spacing. For speeds less than 35 miles per hour, a minimum distance between signs should be 150 to 200 feet. For speeds of 35 to 45 miles per hour, a minimum distance of 200 to 300 feet between signs is needed. For speeds of 45 to 55 miles per hour, 300 to 500 feet is the minimum distance needed between signs. This spacing allows the motorist time to understand and react to the message being given by each sign. Use the same sequence of signs on the opposite end of the work area with the same spacing and arrangement. Place an N construction sign approximately 500 feet beyond both ends of the work zone. Give special consideration to work zones where there is a problem with sight distance due to horizontal or vertical alignment. Hills or curves can reduce the driver's ability to see ahead. Station the flagman the proper distance beyond the Flagman Ahead sign. The flagman stands 200 to 300 feet in advance of the work site. This allows approaching traffic a sufficient distance to slow down before entering the work area. The flagman stands on the shoulder adjacent to the traffic lane that he or she is controlling. The flagman never stands in the lane being used by the moving traffic. Station a flagman on the opposite end of the work area to control traffic from that direction. The flagman must be highly visible by wearing an orange vest and hard hat. Flagmen should be knowledgeable of flagging procedures. Here, the flagman uses the stop-slow paddle. To stop traffic, the stop side of the paddle is turned toward traffic. The uplifted hand also directs traffic to stop. To direct traffic to proceed around the work area, the slow sign is turned toward the traffic. The flagman motions for the traffic to proceed with his free hand. It is important that the two flagmen have clear sight of each other and are in total communication when directing traffic through the work area. Do not allow traffic to proceed through the work zone until the traffic is stopped at the other end. The crew supervisor is responsible for seeing that the traffic signs are placed at the proper location and that flagmen are properly located. Drive through the work zone prior to beginning maintenance operations to be sure that traffic control devices are properly placed. Periodically during the operation, check the traffic control devices to be sure that they are still visible. When the maintenance operation is completed, remove the traffic control devices. Remove the signs in the reverse order in which they were placed. Now, let us discuss traffic control for a continuously moving operation. Moving operations are maintenance activities that move along the road at relatively slow speeds. This diagram illustrates a typical traffic control layout for a continuously moving operation on a two-lane roadway. Note the warning signs that are used. They are the same signs used in the stationary operation. Place them in sequential order, beginning with the road construction ahead sign, then the one-lane road ahead sign, and lastly, the flagman ahead sign. These signs are orange and reflectorized. The minimum size of these signs is 36 by 36 inches for speed limits less than 45 miles per hour. For speeds greater than 45 miles per hour, the minimum size is 48 by 48 inches. The spacing required between these signs varies, depending upon the speed of the traffic on the roadway. For example, for speeds from 35 to 45 miles per hour, the minimum distance between warning signs is 200 to 300 feet. Place these signs ahead of the work zone in each direction. Since the operation will be moving, an extended work zone is used. An extended work zone may reach up to 1 mile in length. As this drawing illustrates, this arrangement of signs would precede the extended work zone from each direction. Station flagman 200 to 300 feet ahead of the work activity. The flagman should stand on the shoulder adjacent to the traffic lane that he is controlling. As the operation moves, the flagmen also move, maintaining 200 to 300 feet between them and the work zone. The two flagmen must have clear sight of each other and be in total communication when directing traffic through the work area. On occasion, a third flagman may be required due to poor sight distance or intersections. Use a stop-slow paddle in all maintenance activities. Flags should only be used in emergency situations. When the operation approaches the end of the extended work zone, suspend work until the signs are moved. The crew supervisor is responsible for seeing that the traffic signs and flagmen are properly located. Periodically throughout the operation, check the traffic control devices to be sure they are still visible. When the maintenance operation is completed and the traffic control devices are no longer needed, remove them immediately. Remove the signs in reverse order of placement. For more information on work zone traffic control, consult the manual on uniform traffic control devices. Proper traffic control is a must for all pavement structure repair techniques. Traffic control protects workers as well as the motorist.